Imagine a world where AI doesn't just assist humans, but learns, reasons, and even creates. Jensen Huang, CEO of NVIDIA, recently presented a powerful vision for India's future in AI, making bold claims about how AI could transform the country's entire tech landscape. Today, we're diving into his insights from the AI Summit in India, where he shared what it takes for India to lead in the AI revolution. In this video, we'll go through Huang's most intriguing points, add our analysis, and discuss what this vision means for India and the world. Let's get started. Jensen starts off by discussing something that's bound to surprise many: the end of Moore's law and the start of a new computing era. Here's what he said.
We can't continue to ride that curve, that free ride. The free ride of Moore's law has ended. We have to now do something different, or depreciation will end. And we now will not enjoy depreciation, but experience inflation, computing inflation.
Did you catch that? He's saying the era of computing getting cheaper every year is over, something many people probably haven't considered. With Moore's law ending, AI is stepping in to drive the next wave of innovation. For India, a country with a huge tech workforce, this signals a shift in how companies will approach innovation and investment in new technology. Jensen goes on to talk about how NVIDIA has taken on this new challenge through accelerated computing and why they're betting on GPUs to drive the future.
The GPU was really the first accelerated computing architecture running CUDA, running computer graphics, a perfect example. We democratized computer graphics as we know it. 3D graphics is now literally everywhere. It could be used as a medium for almost any application. But we felt that long-term, accelerated computing could be far, far more impactful. And so over the last 30 years, we've been on a journey to accelerate one domain of application after another. The reason why this has taken so long is simply because of this. There is no such magical processor that can accelerate everything in the world. Because if you could do that, you would just call it a CPU. You need to reinvent the computing stack from the algorithms to the architecture underneath and connect it to applications on top.
All right, this is huge. He's essentially saying that accelerated computing isn't just a niche, it's now essential. By creating specialized chips, NVIDIA is making it possible to tackle tasks that were once too complex. Think about India's potential here. With a robust tech sector already in place, India could be positioned to lead the adoption of this cutting-edge hardware and software, especially in data-intensive fields like healthcare and finance. One of the most transformative points Jensen makes is about the change from traditional software development to machine learning. This isn't just a technical shift, it's a complete rethink of how software works.
We have gone from coding to machine learning, from developing software to creating artificial intelligence, and from software that prefers to run on CPUs to now neural networks that runs best on GPUs.
Think about that. Instead of programming software manually, we're now training AI to learn on its own. This isn't just a shift in process. It's a shift in who or what is writing the code. In India, where there are millions of software developers, this could be revolutionary. Imagine the impact on the job market and on India's global reputation in tech. Jensen then talks about the unique AI infrastructure NVIDIA is building in India and why it's so crucial to create a strong foundation here. Let's listen.
So the first part of building an AI ecosystem is the AI infrastructure, just as the first part of infrastructure for the internet ecosystem was building the infrastructure of networking. Of course, the infrastructure of networking internet consists of the personal computer, cloud, and internet itself. In the case of AI, it starts with the AI computing infrastructure.
This is fascinating. NVIDIA is investing in AI infrastructure that can support India's linguistic and cultural diversity, from regional dialects to national languages. Jensen calls it the hardest language model region in the world, meaning if India can do this, it sets a model for other countries. With a population of over 1 billion people, the potential impact is enormous. Next, Huang introduces the concept of AI agents, basically AI helpers that make employees super employees. Let's hear what he has to say.
It's really the way you would bring these agents into your company is not unlike the way you would onboard someone who's a new employee. You have to give them training curriculum. You have to fine-tune them, teach them how to use, how to perform the skills, and understand the vocabulary of your company. You evaluate them, and so there are evaluation systems.
Whoa! AI agents that work like digital co-workers, enhancing productivity across all fields? Imagine AI-powered assistants that handle the grunt work so employees can focus on bigger tasks. For Indian tech companies, this could mean deploying agents across customer service, finance, and software development, boosting efficiency and changing how people work. Jensen also dropped a fascinating concept about AI scaling laws, not just for training, but for reasoning or thinking. Let's listen.
Thinking, reasoning, planning comes in, and the more you compute, the higher quality answer you could provide.
All right, this is a game changer. Jensen is saying that AI can improve its answers by thinking longer. This isn't something you hear often about AI, thinking in terms of quality over speed. For India, this could mean developing AI systems that go beyond basic answers to give more insightful, complex responses, which could be a massive advantage in areas like legal tech, research, and healthcare. Finally, Jensen talks about taking AI out of the digital world and into the physical world through what he calls physical AI. This is where it gets especially futuristic.
That next generation of AI needs to understand the physical world. We call it physical AI. In order to create physical AI, we need 3 computers, and we created 3 computers to do so. The DGX computer, which Blackwell, for example, is a reference design and architecture to create things like DGX computers for training the model. That model needs a place to be refined. It needs a place to learn. It needs the place to apply its physical capability, its robotics capability. We call that Omniverse, a virtual world that obeys the laws of physics, where robots can learn to be robots.
Imagine a digital twin of a factory where virtual robots train and perfect their skills before being deployed in real life. For India, a country with an expanding manufacturing sector, this could mean safer, more efficient factories run by AI-trained robots. So Jensen Huang isn't just talking about AI as we know it. He's envisioning a future where AI doesn't just support us, but evolves alongside us, transforming everything from the way we work to the way we build. What do you think? Can India rise to meet this AI challenge and become a leader in this new era of technology? Let me know your thoughts in the comments. And don't forget to like and subscribe if you want to hear more insights like this.